In this video, I'm going to be showing you how to solve Riemann sums using trapezoidal rule. And trapezoidal rule is the most annoying of all the rules because you have to do way more arithmetic. But I'll show you some very easy ways, especially using a table to solve for it in this video, so stay tuned. But first things first, we need to find delta x. We have the function x cubed, but we need to find delta x. Delta x is the distance or the widths of your trapezoids and the distance between each x value for each subinterval. So delta x is calculated by the rightmost x value, 5, minus the leftmost x value within your interval, which is 5 and 1. And we divide it by the amount of subintervals we want, and we get delta x, which is equal to 1. So delta x equals to 1 is the distance between each subinterval. So what does trapezoidal rule look like? Well, it looks like this. You can draw a bunch of rectangles. Now, you might be wondering, why am I drawing left Riemann sums right now? Well, I'm not actually drawing left approximations. I'm drawing the trapezoid. So, the trapezoid here is drawn like this, and I'm connecting the triangles found at the ends of each point, and this is what our trapezoidal rule approximation looks like from 1 to 5. So let's go ahead and calculate all the x values. Since we know that delta x is 1, we can add 1 onto each value past your first number, or your first, the starting point of your subinterval. Sorry, the starting point of your larger interval. So if I add 1, or delta x, to each point, we should get up to 5. So 1, 2, 3, 4, and then 5. We're up to 5 now. Now that we have the x values for each subinterval, we have to write down the y values. So it's a cubic function, so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So each point here along this function, I know it kind of looks off the board, but this yellow dot is on the function. Don't worry about that. But each point is represented by some x and y pair on your table. This is represented by 1, 1. This is 2, 8. This is 3, 27, and so on. So in doing so, in using all these values of these points, we can calculate the heights and the heights of the rectangles and the triangles and the widths of the rectangles and triangles, and we can calculate their corresponding areas to approximate the area under the curve. So how do we do this? Well, first things first, let's go ahead and look at the picture. The height of this rectangle is given by this point, this yellow point to the left. So we use the height of that, 1. We multiply by delta x, which is 1, to get the area of this rectangle. 1 times 1 is the area of this rectangle here. Now, we need to find the area of the triangle on top of it, not the area of the trapezoid. Oh my god. The area of the triangle on top of it. Well, how do you do that? Well, we can find the height of this triangle by subtracting this y value from this y value. Well, the y value, or y of 2, is 8. Right, since this x value is at 2, and this is 3, and this is 4, we already calculate the y value at x equals 2, which is 8. So 8 minus y equals 1 gives us the height of this triangle here. So y of 2 minus y of 1, which is 8 minus 1, is 7. 7 times the base. So the height of the triangle times the base, which is 1. That's 1/2 is the area of the triangle. All right, now we got the area of this region here. Let's shade that in. Let us know that we solve for that. We got the area of this region. We need to find the area of this next region here. Area of next region, we need to find the area of this rectangle first. So the area of the rectangle is given by y of 2 times the base length, since y of 2 is the height of this rectangle. So y of 2 is just 8. 8 times base length, which is delta x, which is 1. We multiply 8 times 1, we get the area of this rectangle. And again, we need to subtract the larger y value from the smaller y value. So y3 minus y2, which y3 is the y value at x equals 3, is 27. 27 minus 8 is 19. 19 times delta x times 1/2 is the area of this triangle. So we got the area of this triangle written down in equation form right now. All right, next thing, y of 3 is the height of this rectangle. So let's go ahead and multiply y of 3, 27, which is 27, times the width. And then again, we subtract y of 4 from y of 3 to get the height of the triangle. And 64, use calculator for this, 64 minus 27 is 37. 37 times the base length times 1/2 is the area of the triangle. So right now, this is the area of the triangle, this is the area of the rectangle. We add them together, we get the area of the trapezoid. Okay, how about the area of this rectangle here? Area of rectangle, or the height of the rectangle, is given by y4. y4 is 64. And we want to multiply it by delta x, which is just 1. And again, find the height of the triangle. We subtract y of 5, which is 125, from y of 4, which is 64. And you should get a height of the triangle of 61. 61 times base times 1/2 is the area of the triangle. So if we evaluate all these and add them together, you should get the total approximated area using trapezoidal rule of this function. I evaluate these guys for you. I pause the video so you guys don't have to watch me type in the calculator. But all these numbers are 4.5, 17.5, 45.5, and 94.5. Okay, I did not add them together in the time I paused the video. Let me add them right now since that won't take that much time. And you should get a total approximated area, if you add them all together, of 162. The trapezoidal rule is probably the closest you can get to a perfect approximation for, well, not a perfect approximation. It's the best approximation you can get compared to right and left rule. But you can test this out, like right now. If you know how to solve the right and left Riemann sums, then you can figure out that the trapezoid Riemann sum approximation is an average of the left and right Riemann sum approximations. It's actually an average of them because of this property of the triangle on top. But let's move on to another problem. I'll show you again how to solve for this. So again, let's go ahead and draw the trapezoids for this. So if we were to draw trapezoids, let's go ahead and draw all the points that intersect with the graph first at our subinterval distances. And what we can do is just draw a triangle here. So this is just a triangle. The first subinterval is simply just a triangle. There's no rectangle because the height of the function is at 0 at this time. But there's a rectangle here that we can draw. Rectangle, triangle, another rectangle here, and another triangle, and another rectangle, and another triangle. Okay, this is a very terrible triangle, but bear with me. But now we need to find delta x. Well, I mean, like 0 to 4 subintervals. That already tells us delta x is equal to 1. But if you want the analytical method, of course, 4 minus 0 over the amount of subintervals you want is equal to your delta x. So we start off with the first number, 0, and we add the subinterval values onto each x value until we reach the end. So the first and last numbers of your table should be equal to the first and last numbers of your macro interval. All right, now that we have this, we can calculate all the y values. The y values are given by the square root of x, so it's the square root of 2, square root of 3, and 2. All right, now that we have this, let's go ahead and calculate each section one by one. So this section just consists of a triangle. So this triangle is given by the heights of y0 and y1. Well, if we subtract y1 from y0, we just get 1 minus 0, which is just 1. So the height of this triangle is 1. The subinterval length, or the base of this triangle, is also 1, so we multiply this 1 and multiply it by 1/2 to get the area of this triangle. Right, base times height times 1/2 is the formula for a triangle. And this is already just 1/2. I'll just write down 0.5 for you guys already. All right, how about this next subinterval? With this next subinterval, you have something more complicated. You have a rectangle and triangle now. But the rectangle is given by the height of y1, and y1 is already determined to be 1. So the area of this rectangle is given by 1 times 1. Well, how do you find the area of this triangle? The area of this triangle is given by the height times base times 1/2. So the height of this triangle is y2 minus y1. y2 minus y1 is square root of 2 minus 1. And we want to multiply this by the, let's put this in parentheses actually, multiply this by the base length of the triangle, which is just 1 times 1/2. Alright, I'll have to plug this to my calculator later. But let's keep going. If I fill this in, let's keep going. The area of this rectangle here is given by y2 times base length. So y2 is the square root of 2 times 1. So this is the area, this part of the equation is the area of your rectangle, this rectangle. And then the area of the triangle is given by, or the height of the triangle is given by y3 minus y2. y3 is square root of 2, square root of 3, minus the y2 value, which is square root of 2. Multiply this by base times 1/2, and you get the area of the triangle, given this equation. This is the area of the rectangle plus the area of the triangle to get the total area of this trapezoid. All right, and lastly, we have the height of this rectangle. Height of this rectangle is given by y3, so we multiply y3 by base plus y4, so y4 minus y3 times base times 1/2. So I just plugged every number into my calculator. This is 1.207. This is 1.573, approximately. It's not equal to these exactly. And this is 1.866. So if I add all these values together, you should get, oops, I forgot to put add there. You should get a total area of 5.146 using trapezoidal approximation. So, as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.